Well, hello and welcome to the second day of NahamCon. If you're not familiar with the second day, all we're doing today is workshops. All the workshops are going to be free. The first workshop we have going on will be with Jeff Foley, the author of Amass. He's going to show us how he uses Amass and how to be efficient while using it. So before we get started, do me a favor, go ahead and check into Discord. Make sure you're looking at all the announcements. We're still doing the IoT Village workshops all day. That's going to be offline within Discord. All you have to do is go to the website and enroll. And if you're liking the content and you want to give back and you want to donate, consider donating to YSIS by going to ysis.org/donate. You can also use the donate command on Discord and go to the link. The way the workshops are going to work is the first workshop is going to be live, but we have a very packed schedule. So if you have any questions, just hold on to it until the end of the workshop. If we have time, we'll make sure to get to it. And if we run out of time and don't have time to come to the questions, we'll make sure to answer all of your questions either on Discord or on Twitter. So if you have any questions, make sure you hold on to them until the end. So let's jump right into it. Please give it up for Jeff. He's going to give us a very cool workshop on Amass. All right, Jeff, thank you so much for doing this, and the floor is yours.
All right. Thank you, Ben. Yeah, I'd like to start by just saying, thank you to NahamCon for inviting me to do this. It's a pleasure to be supporting women in cybersecurity. And I want to thank Quanterion for making it possible for me to make time to prepare all this. And just if you have any additional questions or interests in attack surface management, feel free to reach out to Quanterion. So I've broken this workshop up into an intro to this project, the OWASP Amass project, in case some people aren't familiar with it, and then some basic usage, which could include things that people are not used to doing with it, and then some more advanced usage, which where I address some ways to get better performance from Amass. And then I'm going to use the end of this workshop to cover the new Amass scripting engine, where you can script your own data sources for Amass. All right, so with that, start with, so where do you go get this if you're not already familiar with this? Hopefully everyone can see this.
Yep, we can see it.
But yeah, you should just be able to type in OWASP Amass. It should bring you right to the repo. Just a few things about what to do once you get here. So you can go to releases. These are updated on a pretty regular basis. I would definitely recommend always getting the latest release, since we put out bug fixes pretty frequently. For instance, this one went out last night. We get a lot of great feedback from all the users, so we try to respond as quickly as possible to the issues that they present to us. Also, you can come down a little bit here and find our documentation. So I would definitely recommend, if you haven't already, take a look at this, since there are a lot of things you can do with this tool, and we've tried to capture at least some of it in these documents. But I don't know, I'm not sure how much to assume people know about this already, but in case you're not familiar, just like this says, this tool's focus or scope has always been to provide in-depth attack surface mapping and asset discovery. So it's to try to give you the greatest number of findings possible. And as I'm sure some of you are aware, that hasn't always meant as fast as possible, since it takes longer to find more. And not all the techniques that Amass uses are passive. So we'll get into that in a little bit. So those are the basics I just wanted to cover about the project. If you have any further questions about the project, of course, please feel free to come to our Discord, which you can find right here. That's the preferred location to bring questions, troubleshooting, asking us for help for things like that. If you have problems, like you know for sure there's something wrong with the tool, or a release has broken something, or you just have feature requests, then please feel free to go to the issues. All right, so enough of that, I think. So one thing I wanted to cover before we jump into using this is what is Amass doing when you execute it? Because it's, as I mentioned a moment ago, it's not simply reaching out to data sources, pulling data and getting unique results and printing them out. Amass has a cyclic process where the results from each data source are feeding that engine, that cyclic process, and they are feeding off of each other, right? The results from one are then being fed back into other ones, and they're using that to find more and more and more results, which is why it can take a long time for it to finish, because it only takes one more finding to potentially fire off a lot of additional activity. And Amass attempts to keep that going until it can actually say, there's nothing more I can do. So if you know for sure that you just can't wait for the exhaustive process to complete, then I would recommend using the timeout flag. People have asked questions like, what do I do to address this if I have it in a workflow or something like that, where I'd like to know I can complete it in 2 hours. If that's a requirement, then I would say just use the timeout feature, because then you know it will stop at that point, and the rest of your workflow will continue. All right, so before we go again into me putting hands on the tool, another thing I'd like to show is the configuration file. So this configuration file is the same one that you can get from the repo under examples. And there's a lot of things that you can provide on the command line with Amass that can also be provided in your config file. So a lot of people, including myself, use this as a way to save their fingers from having to type these things over and over again. What I'm going to do today on this call, so that I can aim this at a couple interesting targets, is I'm going to include the target domain in this config file. And then I'm going to turn on the demo feature, which will make it so you only see some of the output, so that we can feel like we're doing the right thing here, not exposing organizations' infrastructure, yet we can get some interesting results to see during the workshop. So I'll be using like these here. So what you're going to see me doing is just providing the config file. Normally, or a lot of people, I think, would be instead putting those arguments on the command line. All right, another important thing is, and I get questions about this a lot, so I wanted to make sure to cover this. So the Amass tool has an output directory, which you can see here in the configuration file. But it's commented out because this is the default value. And actually, interesting, this right here is not, this statement is a little off. So let me explain what is actually happening here. If you fire off Amass with no output directory specified, it picks a location that's based on the OS that you're using. So for this operating system, which is Linux, this is Kali Linux, it should be located under .config Amass, which is where it stores, as you can see, the log file, the JSON output, the text output you would receive if you said -o, and the .bolt file is the local graph database. But there's other things that we're going to get into later in this workshop where if you include them under your output directory, you can get special, Amass will go looking for it there. So it's important to know about it. For instance, if you build yourself a config file and you put it under the output directory, Amass will automatically consume it or use it. There's other files like that, like later I'm going to talk about the scripting engine. There's a special location under this directory where it will look for custom scripts. So this is an important place to know about, but if you don't want to have to remember where these directories are for each OS, like for instance, under Mac OS, it's your home directory, library, application support, Amass. Kind of a long path to be worrying about. It's just easier, in my opinion, to use the -dir flag and just give it a directory that you want to use. But since it needs the directory anyway, and some people just would prefer to use the default and not have to think about it, it uses those special locations or default locations. So I thought I'd mention that since many people have asked about, how exactly does the output directory work, and what is it used for, why is it being created, things like that. I get a lot of questions too about the graph database. So the graph database is not necessary. It is used by default. There's a flag, pretty sure it's no local. No local DB, that's what it is. So if you use this flag, you can cause the local database not to be created. The effect that has on your experience using this tool is that you will not be able to use the tracking features. You will not be able to use the visualization generation, and you will not be able to ask the tool to produce previous discoveries or findings, since it's not going to save it anywhere. But it would cause your workflow, if you're simply going to use the data from, say, an output text file and send it to something else, and you have no intention of using the data later, then it could speed up the process, since it's one less thing that Amass has to handle before it's finished. So it's worth noting or being aware of. The graph database is generated at runtime in memory, but it does not have to save it for you if you don't want it. And the reason it uses the graph database is because graphs are the structure that infrastructure is actually laid out in. It's more natural than, say, a relational database or a list of some type. So it just it works better. It makes it easier to work with the data. All right, so moving along. Another thing I was going to quickly go over is the subcommands. So we will not have time to go in depth on each of these today, but I do want to mention what are these though, or what are the differences between them? So the one that most people, I imagine, are familiar with is this one, right? Because this is the vertical domain name correlation, or DNS enumeration, subdomain enumeration, which many people are fond of. But the other one that is probably of interest as well is Intel. So in the future, I'm thinking of changing these names to be a little bit more clear. I might call them horizontal and vertical, just to make it perfectly clear what the difference is. But the goal of Intel was really to allow you to provide what you know about the target and find more of its attack surface, or more of its infrastructure, more of its namespace, so that you could expand your scope. So if you're not trying to expand your scope, then it's probably not of interest. But if you're looking to know as much about the target, say, organization or network as possible, then Intel would be of interest to you. And I'll mention a few things today about how the two of these can feed each other, which Jason Haddix has covered in the past in some of his previous presentations. Viz is quite simple. It really just takes data that you've already collected and then makes it possible to generate files that can then be used to visualize your discoveries. I personally find this very helpful. I'm a very visual person, and I also like being able to present the findings this way to other people, since I have personally found that people who aren't doing this like we are tend to understand it better when you can point at something and say that this is what that is, this is why it shouldn't be here, things like that. The tracking feature is so that if you're doing these enumerations multiple times against the same target, and your goal when it's all over is you just want to know what showed up or what changed from the last time I did it, don't bother me with the things I already know, then you would like this feature, because it allows you to just get the highlights or just get the changes. What's been removed, what's been added, what has moved to a new location. The DB subcommand is becoming more and more important. It's the command that allows you to take control of your data after it's been collected. We have a lot of work to do on this as we keep moving along with this project, because there's a lot of things that currently I'd like to see users be able to do with this that you can't right now. Right now, you kind of get what you get, and the DB command can tell you what's in there, but for instance, it doesn't really let you make changes to the data, or maybe add things in that you know should be in there. And to be honest, this last one is a little bit of an experimental feature right now. It's just in here at the moment for testing, kind of. Eventually, I'd like to think it could be exactly what it says. It could be if you have a list of names and you just want to resolve all the names and be able to get them into your Amass data, then this would be the subcommand to do it, as opposed to doing a full enumeration. All right. So moving along. So let's see what does this all mean? What does this look like? So I'll start out with what I would guess everyone that's used this before is already familiar with, which is you have a domain name and you'd like to get subdomain enumeration performed against that domain. So, I tend to use these to make sure I can see all the results or all the data available. And then, we'll just put in OWASP.org right now. So what happens right now is it's firing up the engine where the various data sources, the services get fired off, and the engine that sends out the requests are starting to send them out. And then soon you'll see it say that it's engaging. Actually, I'm surprised I'm not seeing it. There we go. But it's engaging the various data sources and asking about OWASP.org. I'm going to have to make this a little bigger, I think. So as you can see, it tells you which source found it first, what the name was, and then what the IP address or addresses was for that name. Now, one thing that many people perhaps wouldn't know is that, let's say that this is the data source that gets reported for finding this. It does not mean that it's the only data source that found it. It's just the first one, or the one that was chosen to be printed. Since there's only really room here to be printing one, but the chances are actually pretty good that there could be several data sources that found the same name. And in the future, we're thinking of creating a DB subcommand like flag or request where you could say, for this name, show me all the sources that found it. I think there's some value in knowing that, because it would allow you to know how likely is it that people can find it. How known is the target or the asset? Because if you found it and says, well, only one data source knew about it, then in your mind you could say, the chances are pretty low that other people know about this. Maybe it hasn't been checked yet for security vulnerabilities. Perhaps it's worth my time to take a look at it relative to some of the other ones. So anyway, this is a small domain, right? Got a very small number of names. It only found the results from a few places, and they all are under Cloudflare. So it gives you the summary information at the end. It indicates that it's finished, and then it moves on to, if you didn't turn off the local DB storage, then it migrates the data into the local DB. That's, in my mind at least, typical usage of this tool. Many people I've seen on Twitter use this in passive mode. I would argue if you use it that way, you are guaranteeing probably that it's going to be faster to complete, but you're also only using Amass for the most basic of capabilities that it has. You're only engaging the data sources, pulling the results, and printing them out. It doesn't even allow Amass to validate that the names are still being used or still in the DNS records of the target organization. So it's extremely limited. It's just faster because there's less work to do. But if you take off the passive flag, it's pulling the same data, but now it's checking that those names are still legitimate, or they're still valid. And it allows you to get the additional information of not just that what are the names, but what are the IP addresses. And it allows you to find more of the infrastructure for the target organization. And it's going to find more names that the passive data sources didn't know. For instance, by using things like reverse DNS queries and things like that. All right, let me check how we're doing on time here. Ben, real quick, do we have any questions at the moment about output or what I've covered so far? Or is everyone holding their questions as asked? All right, I'll assume that's no, and we'll continue moving forward. So that's basic usage, or what I would call basic usage. Once you have this information, though, as I mentioned earlier, there's other things you can do with it. So right now, if I bring this to the top of the screen, if I type Amass and I say DB, and I'll just say, show me the summary information for owasp.org. So it will print the same thing we saw a moment ago when it completed the enumeration. The thing that's interesting about doing it this way, though, is if you've done that enumeration 10 times, say over the course of, I don't know, a couple of weeks, this summary information will include all the information you've collected. So each enumeration isn't guaranteed to give you the same results, right? It depends on how each data source behaved. It depends on how the resolvers behaved that you queried for the names. There's all sorts of reasons why you could get different answers each time you fire this off. Also, though, if you have data in the database, Amass pulls the data as input for future enumerations against the same target. So if I do another owasp.org enumeration, all those names that showed up the first time, which we can look at just by typing this. So all those will end up in the next enumeration. They'll just get added in immediately in order to encourage consistency from one enumeration to the next, so that we're not missing anything we already knew about, assuming it's still there. Which hopefully the effect of that is that every time you run this, you should only be getting more and more results, as long as you're not wiping out the database in between executions. So that's a nice feature. It also helps the tracking, so that again, it creates consistency so that hopefully if you're using tracking and it says, you know, a name was, you know, removed, hopefully that actually means it was removed, not just that you didn't get lucky this time and discover it. All right, so another thing you can do once the data's in the database is visualize it. So what you're seeing here is this a lot to see here, but D3 is the format that I'm going to ask it to export the data in, which allows us to open it up in a browser because it's got HTML around it, and allows us to just look at the results in the web browser. So it's nice when you have a small number of findings, because I would say D3 can probably handle, at least with the way I'm using it, up to maybe 1,000 discoveries. If you start getting higher than that, it starts getting overwhelmed, I think, and you probably want to consider other formats, other programs to visualize it. So if we D3, tell it wasp.org, should end up with our D3 information in the output directory. Let's see about that. So there it is. Take a look at it. Here. That's interesting. I imagine, though, what we're hoping to see is right here. So, yeah, this isn't the most interesting graph to look at, but that's your domain. These are the subdomains. These are the addresses, which the fact that they're so huge probably means a lot of these are pointing to the same addresses. Maybe all of them are pointing to the same ones, which is, I think, what we saw earlier. And we have the different net blocks the IP addresses belong to, the AS information, and we've got some pointer records that are pointing back to some of these names. And that's about it. You know, larger targets give you more interesting things to look at, but anyway, that's how you would output that and open it up quick to take a look at it. If you had a more interesting graph, you'd probably have structure more interesting to look at, which could give you ideas for where you want to spend your time investigating the assets. Maybe where you would, if you start to see, say, a lot of names that are indicating maybe there's development activity going on there, or, you know, things that would cause people to make bad decisions and could be, again, worth looking into more. Perhaps you'd hone in on those parts of their network. I also notice you can just quickly see relationships between organizations, you know, such as people using certain services, and, you know, it's interesting to be able to quickly pull that out of the visualization. Whereas, you know, trying to glean that from, you know, a list of names and IP addresses, at least for me, is not quite as easy. All right, so I think this would be a good time to move along to not just basic usage, but I mean, if you haven't noticed already, I'm skimming and trying to hit points that I feel I get a lot of questions on our Discord server about. If I were going to try to cover everything about this tool, we'd have to have probably a full day training session or something like that. I've done training sessions in the past where they're at least twice as long as this workshop, and still I, at the end, feel like there's more to talk about. So I'm trying to use this as an opportunity to share with people answers to questions I feel like I get frequently, so that in the future people would have a place to go get answers to these things faster. So one thing I use a lot, and I'm not sure everyone realizes is at their disposal, is the include flag. Pull this up again. So include and exclude allow you to control which data sources are being used during your enumeration. So perhaps you know for sure that you just don't want to use some data sources. Maybe you know that you only want to use a few, or you'd like to see only what comes back from those. So there's some ways that you can leverage this in order to, I would say, get finer grained control over what happens when you execute Amass. So for instance, as an example, if I say Amass enum So actually, let me mention one more thing. If you say passive, what this will do for you when you're using the include flag is it will allow you to say, I'm only going to mention one data source, and I just want it printed out. I really don't want anything else done with it, or almost pretty much nothing done with it. I just want to see the results that come from it. So if you say passive and include, and let's just, I don't know, we'll use this one. Fire that off. What should happen is that it's only going to ask that one data source for the subdomains for owasp.org, and it's just going to print it out. So there's some things that happen anyway in the engine, the Amass engine, that you really just can't avoid. Like for instance, it's going to do this no matter what. This first one here. But for the most part, all you're going to get is exactly what you requested. So that can be a helpful feature. I mean, I use that all the time when I'm testing. If I want to say, look, I just want to see what happens when I engage that one data source, and that it's going to give me what I'm expecting it to give me. But I imagine that could be pretty useful for people who want to have that kind of fine-grained control over their enumeration process. The other similar thing here is, now let's say you wanted to do something like that, but you didn't want passive. One thing that I don't think enough people realize is if you were to just fire this off right here, it's probably not going to do quite what you had in mind. Because what will happen is you're now asking it to go get the names for the subdomain names for owasp.org. But then when the rest of the process attempts to get IP addresses, which it will do, it'll get IP addresses because the DNS will take care of that. But then when it's going to take those IP addresses and attempt to get network or infrastructure information about what network does that IP address reside in, it's going to not be able to find that because CRTSH does not provide that information. So if the effect you're looking for is, I want to run Amass not in passive mode, I want it in normal mode, but the only data source that produces names that I want to use is CRTSH, then you actually need to do something more like this, where you give it the name data source and the data source capable of looking up the infrastructure information. So that way, it will be able to get all the data necessary to produce or build the database. So for instance, if it wasn't able to do that, you wouldn't see these things getting printed out right now. The only reason they don't have IP addresses at the end is because I didn't ask Amass to give it to me as the command line flag. But if it wasn't using RADB to get the AS information, then these things wouldn't be getting printed out. And it wouldn't be able to tell you what ASN, these things were on. Excuse me. So that, I think, is something that, I've had people come and ask how they can have that kind of control over their enumeration, but, I think maybe the project hasn't communicated all this as well as possible, or as well as we could. So here's us making our first attempt. I already told Ben in previous discussions that, this project has goals to clarify some of this in our documentation in the future. We just have a lot of things going on and haven't managed to do this as of now. All right, so that's what I wanted to show, at least with the include exclude, and just having better control over your data sources. You'll probably find this all very useful too as we move to the discussion of the scripting engine, because when you want to only fire off your custom scripts, you're going to want to know how to do this. Otherwise, you're going to find you're running your scripts along with all the other data sources, and it'll be hard to tell what kind of performance you're getting from your data sources. So you'll probably like this as time goes on. All right. So another thing I was going to mention, I don't think I'm going to spend a lot of time on this, but I was going to show it, is so Amass does not by default perform brute forcing, but it will. So it's not that difficult to do, right? So if we're doing our typical enumeration, we say, yeah, we want to see where these things are coming from. You can just say brute. And what this will give you, if that's all you give it, is it will turn on brute forcing with the default configurations and with the default word list. That being the big one, right? Because most people, of course, have their own word lists or ones that they'd prefer to be using. So if you give it the -W flag, then you can provide any word list you like, and it will use that instead. Keeping in mind, of course, though, the default behavior of this brute forcing, if you execute it like this, is it's recursive brute forcing. So the default value, which I think is in here, if I'm correct about that. If not, then we're going to have to make sure it makes its way in. All right, right here. So brute forcing, it is not enabled by default because these are commented out. But if you enable it, it is recursive by default. You can turn that off. Let's see, number of, all right, so this is actually out of date. Good thing I'm going through all these. We're gonna have to update these, but this value by default is 1, not 0. So what does this mean? So the min for recursive value is, it means, come up here. If I have, you know, example.com or something like that, that's our domain. Now that is going to be brute forced right away. Like we're gonna end up, for instance, trying, you know, these kinds of names no matter what. But what happened? The question becomes: so what happens if it discovers another name? I'm just thinking of one, like, just make something up, but discovers this. You know, people have often asked the project, so what does the recursive brute forcing do? Does it find that and then just automatically start brute forcing, you know, for instance, trying something like that? So the answer is, the default is no. The default behavior is until one label shows up off of this one, like that. When that name shows up or something like it, then it says, okay, we've now seen evidence that there's names off of this label. And let's start the recursive brute forcing, meaning let's take the entire word list and apply it to this. So if this was still 0, the answer would have been, we just start right away brute forcing. The default value of this is 1. So like I said, it has to see 1 before it will start. The way I think of that is, it needs to see evidence that it's worth doing the recursive brute forcing before it does it. But what if, for instance, for your target organization that you're working against, you know, you're doing your bug bounty, what if you happen to know that 1 isn't enough? Maybe every subdomain or far too many of them have www, but it doesn't necessarily mean that it's worth doing the recursive brute forcing. Well, so you could change the value to 2 or 3. But what if you're in the different position? What if your attitude about it is, I want to do it, I want to brute force everything? Well, then set it back to 0, and then it will. It's going to take a lot longer, but it will brute force everything it can. So these are important values that I've had a lot of people come to me and say they're not sure what these mean, or they don't know how this works. Another thing I unfortunately don't have time to cover during this talk is that we provide the ability to do masking, which allows you even greater flexibility in your brute forcing. Like I said, unfortunately, I had to leave that out of this talk. But I'd recommend, if this is important to you, you probably want to go find out what that is, because it's a feature that is available to parts of our brute forcing. All right. I could probably spend a lot of time on this. Like I said, I have to cut the portion on brute forcing a little short. But like I said, it's pretty typical for me to use Amass, where I just run it, like this. I mean, not against this target, but like that would be typical use for me, where I activate, those two types of pieces of output that I like to see. I turn on brute forcing, and I give it the target. You can also specify a list of targets. I haven't done that during the discussion, but df allows you to give it a text file where it could be domains.txt or something like that, and it can ingest however many domains you need. Although I wouldn't necessarily encourage doing all of them at once if you don't really need to. Instead, maybe the ones that have a relationship with each other. And then, because the more you try to do at once, the more memory you're going to use. So I would keep it in reasonable chunks if you can. Although we've also worked lately to try to keep memory consumption down, so it's been doing much better these days. But I wouldn't say it's impossible to overwhelm it if you give it too much to do. All right, so I'd like to move on to a topic that I feel a lot of people are going to get value out of, and I only have a little bit longer to cover it, so let's move on to that. So in the past, I've gotten lots of questions about, so how can I get Amass to go even faster? And the speed that this tool goes at is very related to the number of DNS resolvers that you give it to work with. So the default number of resolvers that it has to work with, I believe, is something like 8. And they're fairly high performance resolvers and reliable. But I would also say, if you're using them a lot and you only have 8 to work with, then you're coming from the same IP. That's another thing that changes the game quite a bit. But assuming for this discussion that you're coming from the same IP address, they will eventually figure out that you're abusing their service, so to speak, and you'll start getting throttled, either by the resolvers or by the authoritative name server for your target. Not for every single one, but all too many, I feel this happen. All too often, this happens to me. But it won't happen quite as much, or maybe not at all, if you give Amass more resolvers to work with, and if you're changing the resolvers, on a regular basis. So for this discussion, what I'd like to encourage is, before this workshop, I ran DNS Validator. So I imagine many people are familiar with what that is, but just in case you're not, all right, so this is your friend if you haven't taken a look at it already. So what I do with this personally is I build the Docker image and I run it just like they say, except I give it quite a few more threads to run, but that's my, to each their own, because they warn you, if you bring that number up too high, you're probably gonna regret it. But for instance, like I don't have any problem running it with 100 or 200 threads, but this works really well, and it's pretty easy to you don't have to think too hard about this. When it's all over, you just end up with a file called resolvers.txt, and it can easily have, say, something like 9,000 public DNS servers to work with. So I would definitely recommend, in case you can't see this, let's this and put that right there. So I would definitely recommend you take a look at that. Now, one little thing I'll throw in there though. So I use this pretty regularly. You know, I appreciate all the work that was put into making this, but at the same time, it does not prevent all. It doesn't make it so all the resolvers you get are good resolvers. So what do I mean by that? So first of all, you're going to get varying performance, right? Because there's no telling. So whose resolvers are these, or servers are these? Where are they being hosted? What's the latency on them? But also, perhaps more concerning, some of them will look legitimate to the validator, and then when you go use them for a while, they could start giving you false or malicious results. So sometimes you have to play with your resolver list quite a bit before you find, say, a healthy list that is working well for you. It's a little bit annoying, but I would still say it's certainly better than not using this, because it's going to find weed out a lot of the bad ones for you, increasing the chances that you can produce a good list. But going a little further, I don't just take 9,000 resolvers and now say, Amass, please utilize 9,000 resolvers. What I do is, so I have the file produced already right here. So I did it. Oh, nice. Okay. So I made this before the workshop, but it's got a lot of resolvers in it, right? So what I do is, for a given target where I have an idea maybe of how large it is, and how, maybe I even know how sensitive they are to, the requests coming from the same resolvers, or how likely they are to pick up on my activity and throttle me and things like that. I'll decide how many do I think I need. But to be honest, I think I do well oftentimes with like 25 or 50 or 100. You certainly don't need 1,000. At least I really don't think you do. So what I do is I take the list that we have right here, and I say sort, randomize, and then I just take the number I want. So let's say it's 25, and then I'll call that 25 result. So now we just have that many, but that's a good number. It really is. It works quite well for me. If I have that many and they're working well for me, I don't tend to have problems usually against even large targets where it could take hours to finish the whole entire enumeration. But with that many, you tend to stay under the radar. So, but you're going to have to ask yourself something when you start tweaking these things with Amass. So let's assume we now have 25 resolvers, right? And if we're going to use them, you would use the RF flag and say, I want to use my 25 resolvers. But the maximum number of DNS queries that Amass is going to send out at any given moment is the default value for that is tweaked to the number of default resolvers. So if you just fire this off with your other arguments, you're going to find that it's probably not as fast as you would like. So you're going to need to set this value right here. If you really want to see like decent performance, I would say you're going to need to set that value, and you probably want it to be, I mean, I would say play with this and come up with your own conclusion about this, but I like to keep the numbers so that at any given moment, each of those 25 resolvers could have between 500 and 1,000 queries being sent to it. So, you know, you might want to say 25,000 or maybe 20,000, you know, something like that. I mean, just the other night, I had something like this set up where this is the way I had it set up. I had my 25 resolvers. They were working well for me. And I had the max set to 20,000. And I was quite happy with the consistent high performance I was seeing. But you need to be aware of, which again, this is on my shoulders. We need to get this more documented. But these are the kinds of things that if you really want to have complete control over what's happening with Amass, you need to be aware of these configuration options. But this is the kind of thing that will allow you to take more control over the performance of Amass. Now, I'll also say it won't necessarily mean that these enumerations are going to finish lightning fast. What you could find is by having your queries spread out better, you could end up getting more results, which are only going to cause more, you know, events to take place within Amass, and it's going to ask more questions. So, you know, there's other things, of course, to consider. Like earlier I mentioned, be careful how much you want brute forcing to fire off, because that's certainly going to create a lot of additional traffic. If you aren't interested in name alterations, which personally I really like name alterations, but if you don't have any interest in it, then turn them off. So that way you're reducing, you know, the additional traffic that it creates. I personally don't really find myself ever turning them off because I think it's amazing how many results come back from name alterations, and it also allows for the alt and sweep effect, where you're permuting names, they're finding new subnets, and then you're doing reverse DNS sweeps in those subnets, then finding new names, which then get altered or permuted again, and the cycle just keeps going. I'm not sure I would ever give that up. I think it's a powerful effect. All right, so those are the things I wanted to show for advanced features that I feel like these are things that, you know, I don't see people talking about on Twitter, but I do get questions coming to the Discord server from some users about how they can have better control over these aspects of the tool. So I thought this would be a good place to share it with, hopefully, a lot of people. I mean, I could be running these, right, to show you just how, you know, the impact that it has, but I think it would use up a lot of our time. And what I'm going to do instead is I'd like to use that time we have available to show you this new scripting engine, where I will show you, we will run it a couple times to actually see what's happening here. At this point, though, I think we're at a good spot. We're at about 1 hour. I think it'd be good to do a quick, just 5-minute break. And I'll be right back, and then we'll pick up with the scripting engine.
Yeah, no worries, Jeff. Yeah, everyone will take a 5-minute break and then we'll continue with our workshop with Amass while we wait. Since, again, this is the second day, we have one more workshop coming up with Jason Haddix on the bug bounty hunters methodology, the fourth version of it. This is the first time Haddix is actually presenting this, which I'm really, really excited about. But while we wait, a few announcements. If you are a new subscriber, just make sure you link your Discord and your Twitch. All subscribers do actually get their own drops every once in a while. If you're enjoying the material, you enjoy the conversations, you enjoy all of these different talks and workshops, and you want to, oops, sorry, my phone's going off. I was listening on this on Twitch. But if you want to donate and give back, do me a favor. Go to ysys.org/donate. Every dollar counts, even if it is $5, $1, $2. There's 500 people here. If everybody donates $2, we have raised 1,000 for YSys within minutes. So do me a favor. If you're enjoying it, head over there and make a donation. And last but not least, there's also an IoT workshop happening. So if you want to, go enjoy the IoT stuff and you want to learn about IoT hacking, go ahead and head over to Discord and go to the IoT Village and make sure you check out their content. And also there's 500 people here watching right now. Let us know if you're not a bot. Drop me an emote. Tell me where you're watching this live from. Are you in the US? Somewhere in Europe? APAC? Let us know where you're at. I want to hear everybody drop something in the chat. Let's see how many people are actually listening and not just walking away or being a bot. See, India, Romania, US, Chile, Mars, Brazil, Germany, Europe, hello from Jordan, Canada, Beep Boop, what's up, JP? Russia, India, Jamaica, Nashville, Panama, Canada, UK, there's a lot of people here. Iran, South Africa, Portugal, India, North Korea, that's far. Texas, baby. What up, Texas? Indonesia, San Diego, Iceland, Puerto Rico. All right, there's not a lot of bots in here today. We're good. Alabama, West Virginia, Denver. All right, now drop your addresses. Let's dox yourselves. I'm kidding. Watching from NahamSec's house. All right. All right, let's give Jeff a few more minutes. Let's take some time to stretch. Get some coffee, get some drinks. And we'll continue with the Amass workshop. All right, we're back again with Jeff Foley. We're going to carry on with our Amass Bootcamp. You're up, Jeff.
Excellent. Thank you, Ben. Yeah, so we're back and we're switching gears to the new Amass scripting engine. So this scripting engine allows you to create your own data sources for Amass. Now, eventually, you know, what it means to be a data source could be, you know, just about anything. It could be your own brute forcing, you know, algorithms, or your own name permutation algorithms. It could be firing off a local program or accessing, you know, your own database or something like that, and then bringing the results in to the enumeration process. You know, the sky could be the limit pretty much on what exactly could you pull in to Amass, but it would pull it in on request. Just like all these other data sources, they're receiving these events from the engine saying, we want, you know, names for this domain name, and then it's listening for the answers coming back. So it would just make it possible for your script to be one of those services or that are listening and able to respond to those requests. All right, so what I thought I would use as an example today is, I'm sure you know, many people are familiar with Tom Nom Nom and his excellent work that he's done and his asset finder. You know, Tom Nom Nom spoke yesterday at this conference, and you know, I thought I would use his program as an example of a program that you could pull into your Amass enumeration. So before we just jump right into it, though, taking a couple steps back, I mentioned earlier that scripts can be found within your output directory. So what I'm going to do here is we're going to create our own output directory, so we're not messing around with the default one. So I'm going to create it and just call it, I don't know, let's call it test. It could be called anything. So that's just an empty directory, but now we're going to create scripts. So I have a script that I've written. And what I'd like to do to save us some time is I'm going to just open it up, and I'm going to go through the various parts of this script to explain what are the critical portions of this script. What do they mean? What does Amass do with them? Things like that. Second here. I have a feeling, though. Yeah, we don't want that. Ah, that didn't do me any good. Well, what I'll do is I'll rename it. All right, so we're going to put this into our scripts. Okay, so first thing actually I'll show you is that the Amass scripting engine uses Lua, which is also, you're probably familiar with the fact that that's what Nmap uses. There's lots of tools out there that use Lua. So this is a very basic Amass data source script. So a couple things to take note of. As you can see in the name right here, it has to be named .ads, or it won't be recognized by the Amass scripting engine. But it is Lua. So what we have in this script is, here, I'll change this. We'll call it Asset Finder. Or I suppose we could just leave it like that. And actually, it should be this type, which stands for external. So that's just a way to say it came from outside of. I mean, unless you know for sure that your implementation, for instance, is using a certain type of data source like an API, or it's scraping a web page, or something like that. But in this case, since we're using another tool that could be doing any number of things to get the data, it'd probably be easier to say external. And you can find details on, well, how do I know what the types are? It's in the documentation in the Amass repo. But these two values have to be set. So if you create a script and it doesn't find this global variable and this global variable, it will not load your script. So you could have, whatever file name .ads, and then when it tries to load the Lua chunks. So first of all, if it's not Lua, that will quickly end the whole process right there. But if it is, and it doesn't find those two global variables defined, then it will not load your data source. So these are very important. Then what you're seeing here and here are two of the possible callbacks that Amass uses to call into the scripts. So in this case, the start, callback, as you can imagine, is the one that gets called before any of the other callbacks and gives your script an opportunity to do some initial setup. In this case, it's just setting the rate limit for the data source, which actually we don't even need necessarily for Asset Finder. So we could just take this out. But if you want a rate limit, that's the proper way to do it. Would be when your data source first starts, set the rate limit, because then these other callbacks will not fire off any faster than once per that many seconds. And there's ways to, within your, say, algorithms, ask it to check the rate limit again if you're accessing the data source more than once and you need to adhere to the rate limit. And there's a handful of these Amass custom function calls that similar to set rate limit that are defined in the documentation. So the vertical call is the one that gets called when, as we've seen so far, when Amass says, okay, I've got a domain name and I want subdomain names, it calls vertical. So in this case, all we're going to do is we're going to find asset finder. So the way we're going to do that is I'm going to create another directory under my output directory. And then we'll copy asset finder into there. So that way the binary is in a location that's easily found by Amass. So this way it's output directory /bin asset finder, and then we're just going to give it the appropriate arguments, and we will execute it and gather the output, and then just go through the lines of output and send them along to Amass as new names, or potentially new names, and then close it, and then we're done. So there's a handful, though, of these callbacks. So if you're really interested in doing this, you're definitely going to want to take a look at this. So real quick, let's just make sure everyone's aware of, so where can you find this? So if we go down documentation, this is the manual right here. So it covers at least the basics of the script format, like I said, the various types of scripts or data sources. There's some things that are made available into your Lua environment from Amass that are related to the type of activity that these scripts are likely to be involved in. Including, for instance, if you've put API key, say, information in the config file, if we go down here, let's say you created a new entry in here where it's named the same thing as this name. So I mean, Asset Finder, of course, doesn't have an API key, but, or at least not. I mean, maybe it looks like it supports using API keys, but anyway, let's just say we had a way to use it. So you'd write it in here, and then you could say API key, API key, and then put the API key in here. And then when you get into your Lua script, you would have this table already exported into your environment. So you would be able to check if it's nil, and it wouldn't be. And then you would be able to go get API.key, and it's going to be equal to whatever value is over here. So these are the kinds of convenience things that are, there's going to be more and more of those kinds of things made available to these scripts. Like, for instance, this isn't available yet, but we're going to put it in. The word lists are going to be made available, and other things that are going to be necessary if you want to take full advantage of scripting for Amass. But moving along, these are these callbacks I was talking about. So you've got start, stop, vertical, horizontal, resolved for each name that was successfully resolved by DNS. You've got callback, which only gets called when it's a what I call a proper subdomain name, where earlier I mentioned, for instance, ftp.example.com would have been a proper subdomain once we discovered that www.ftp.example.com existed. So when that happens, this gets called and it tells you how many times one of those labels like www has shown up within the proper subdomain. We've got address for the IP addresses that have been determined related to the enumeration, requests for ASN information, and then these are the convenience functions that are currently implemented, like logging, letting the engine know that there's activity. So essentially don't stop yet because there's more going on. As we've already seen, obtaining the output directory, checking if a name is in scope, setting the rate limit, checking the rate, if checking meaning block until the rate limit has expired, or it's safe to continue. Find is a regular expression pattern matching function, so is submatch. Request is for request, it's HTTP client requests. Scrape is very similar, it's just that it doesn't actually give you back the response, it just scrapes it for names that are being names that are of interest. Crawl does something similar to that, but of course it doesn't just scrape the one response, it continues looking for more pages to spider. And then these are primarily ways to send back discovered data, like new name, associated names are for the horizontal domain name correlation. So this would be like another domain name that's associated with this domain name. New IP addresses, new ASN information. Those are the things that are currently available. And like I said, it's going to grow as we continue to add features. But let's see what this ends up looking like. So we have our script. So if here's how we'll keep this simple as possible. So we'll do enum dir test source, and let's just do passive right now. Include asset finder. So this should only fire off our custom script and just print out the results without further analysis. See if it likes us. So it looks like it loaded it, it's running it, and that's what it discovered, and it's printing out. So of course, this is maybe a little bit of a silly example, because of course you could just run this yourself, but maybe not, right? Maybe you would like to take these various tools that you're using, wrap them up like this so that you only have to actually use one tool like Amass to drive your reconnaissance process, and you would just know it's going to pull in the data from all these different tools and use all of it and bring all the names into the cyclic process I mentioned earlier. And I guess you could say take full advantage of all the data that you can get your hands on. And I don't know about you, but I think this is a pretty small amount of code to write to be able to pull something like that in. And like I said, I mean, some of it's just not even necessary. Like I would argue for this particular script, you don't really need that. You can just write this. So that was a simple script I put together just to demonstrate how you could easily take a command line tool that could find you, say, more names, and then have it called upon when Amass wants it, and it becomes part of the Amass enumeration process. But in the future, this could just as easily be, as I mentioned earlier, you could be accessing a private database, and it could be pulling the results from that. It could be anything you want. So that using Amass now could be customized. It could have your, say, secret sauce rolled into it, right? Things that it's not just doing what it's doing for everyone else. It can be doing what you need it to do for you. It also could be a nice way, if you're looking to contribute back, to easily now write up new ways of getting names or getting infrastructure information and contributing it back to the OWASP Amass project. Because, you know, I would say writing these small little Lua scripts is really easy and not very time consuming. And before you know it, we're going to have all the data sources written up this way. About half of them have already been ported over. You know, this is how we'll be accepting contributions for new data sources. All right, so that went pretty quick. I mean, I don't know how fire-hosed everyone feels about that. Obviously, I don't have time to teach Lua. So if people, you know, there's some really good resources for Lua out there. If you go back to the documentation I was showing a moment ago, the OWASP Amass documentation for the scripting, there's references in there for where to find freely available documentation and even books for how to use Lua. But honestly, it's extremely easy, and it's a powerful language for this kind of work where it's just data crunching. You know, it's just get me some data, put it into the format I want it in, send it away. So it works really good for this. Some of you perhaps are already familiar with it since so many video games use Lua as their scripting language. It's quite popular. So Ben, it looks like this worked out pretty well. I have a little bit of few things to conclude, but then we could open the floor for about, say, 15 minutes worth of questions, if that sounds good to you. I just wanted to mention a few, going back to project-centric things. So we made a couple changes recently that I was hoping to share. Let me bring this back up. So if you find you have a question about OWASP Amass, we definitely want to help you. But I would really prefer, the project would prefer that not take the concerns or the questions or the troubleshooting requests to the GitHub issues. I'd really prefer that most of these questions started in the Discord server, and then if it's determined that, oh, this isn't just a a troubleshooting, let's support or help the community, this is a problem with the project, then we can take it to the issues and officially post the problem so that we remember to take care of it. But what I don't want to see happening is that we get a pile of people's questions in the issues, and it makes it hard for people to use the issues for what they're really there for, which is to keep track of what we're working on and the problems that we've validated are true problems with the project. So that's kind of the protocol I'm hoping we can achieve, is that everything starts in the Discord. We can talk, we can help people, we can take it to DMs and try to make sure that you're getting it working or getting the right experience. But we only are posting things in the issues when it's a real issue. It's a serious issue. Also, if you know that you are writing about Amass, or you have things you'd like to share with the community, the Amass community or the people using it, please don't hesitate to come to the, again, either the Discord server or, to let us know, or just create a PR, and you can add it to our Hall of Fame, where we're trying to do our best to keep track of, or sorry, not Hall of Fame, the references. We're trying to keep track of, the people that are taking the time to share good things with the community about how to use this, how they're getting success with it, things like that. So, we've tried to keep track of some of this stuff. People have let us know, but definitely don't hesitate to bring it to our attention so we can get you in the list. Because I really appreciate everything everyone's doing and the time people are taking to write about these experiences that they're having. And the last thing on this note was, if you'd like to become a contributor, so you feel that you like Go as much as we do, and maybe you like now you could add Lua to the list. But if these seem like fun things for you and you'd like to contribute to this project, we're always interested in talking with people about people becoming contributors. So, I get the feeling when I've spoken with people about this that there's this attitude like maybe they're not good enough at this to contribute, or they don't feel they know enough about it yet. But personally, I don't look at things that way. I'd prefer to think if you're excited about it or you have the motivation, we can help you to say season your skill, get your skills where they need to be, or that you'll just pick it up as you put your hands on it. So, I'm willing to invest the cycles for people who are willing to do the same for the project. So don't hesitate to come and speak with us about becoming a contributor if that's of interest to you. All right, so with that, I think we're at a good point here. This leaves us with, Ben, maybe about 15 minutes to answer questions.
Yeah, sounds good. So again, thank you again for doing this with us, Jeff. Chat, if you have any questions, make sure you drop them in the Twitch chat right now, and maybe we can get to a few questions before we head out and take a quick break for our next workshop with Jason Haddix.
So yeah, Ben, I'm not watching the questions coming in, so if you could maybe do me the favor of picking out the ones you think should be answered, just let
Yeah.
me know.
Somebody's asking, they said, what is the difference between Amass enum active and only Amass enum -d?
Yeah, no, that's a good question. Yeah, so I guess you could say there's like 3 different modes that Amass supports, right? There's passive, there's just normal, which is when you just say -d or you don't specify the mode, and then there's active. So, you know, I already mentioned earlier, passive is simply grabbing it from the data sources and, you know, creating the unique list and printing it out. Normal is when we're taking the data sources, we're getting the names, and we are resolving those names and getting the IP addresses. So that's where it becomes not completely passive anymore. And we're doing, you know, we're finding out all the other infrastructure information, but we're not sending any traffic directly to the target organization, right? So let's say we received a name and we got an IP address and we wanted to do something more like ask their web server directly for TLS certificates. That's something that the active mode will do. The normal mode won't. The active mode is also a bit more aggressive with the reverse DNS than it is in the normal mode. Also, active mode will attempt DNS zone transfers, but it will not do that in the normal mode.
Very cool. You mentioned the DNS subcommand was kind of in beta testing. What are the future plans for that feature exactly?
Yeah, so the subcommand I think they're referring to is the DNS subcommand. So the future I think it has is it would be a way that you could say, so I just have a list of names and I want to resolve them, similar to perhaps what you would do with like mass DNS or something like that. But the point of doing it with Amass would be so that the findings can be put into the database. So it's not really, you know, I'm not trying to replace existing tools like mass DNS. We were thinking of rolling it in for the purpose of, if you have that list and you want to make sure that all those findings are being brought into your Amass database, then we're providing a way to do that.
Security asked the question about what is the benefit to limit the amount of resolvers? Is it the shorter runtime? Anything else besides that, maybe?
That's a good question. So a couple things, at least with the current situation when it comes to obtaining the list of resolvers. In my experience, the larger the list you give it, the more you're inviting malicious resolvers or not, you know, unreliable resolvers to get into the list. So I always ask myself the question, how many do we need? But, you know, we don't need to be going higher than that because the larger the list, the more I seem to end up fighting with it until it gets to be a good list. Maybe that's something that, you know, if we could work further on validating the DNS resolvers, you know, we wouldn't have to worry about things like that. The other reason, though, is you are also bringing in, as I mentioned earlier, more resolvers of varying performance. So while Amass does try to notice which resolvers are performing better and then use them more so that it's pushing the names through as fast as it can, it's not perfect, and if you bring in a lot of poor performing resolvers, you are going to slow down your process a bit. The other thing, of course, is there's only so many of those you can fire up in a single process before it just kind of gets to be too much. Like, you can't have all 9,000 of them running at the same time. Not likely. I'd have to double check what the exact limit is, but every resolver you instantiate within Amass creates 2 file handles. So while that's not that bad, it could be worse. There is a limit to how many you can create in a single process, at least in some OSs. You know, I suppose, for instance, I think on Kali, there is no limit. So maybe it wouldn't matter, but it's also just more work. You know, more resolvers equals more messages that have to be passed around. I would say there's really no reason to have more than, say, like 500 of them.
Yeah, Jason's asking if there's any options coming to distribute Amass over a cluster to avoid rate limiting and other badness.
Yeah, so I've been speaking with some people in the community about, so there's already been some effort put into the Amass project to make it so that in the future we could easily have what you might think of as like Amass agents, so that only a slice of your enumeration process would exist within each agent, and they would work in a distributed fashion. And the fact that we're already using messaging, like event-based messaging within the architecture, makes it so that, let's say you were to, you know, put this into the cloud, it would be quite easy to then send the messages, you know, within the cloud to the various like microservices or places where these agents are being run. So we've definitely thought of these things. It's not ready to do this yet, but I'd like to think that that could be part of the future of this project, is that eventually you could deploy this, you know, across more than just a single hosted environment or a single machine. And, you know, by running it that way, it'd also be easy to rotate IPs, things like that, so that it would be pretty hard for people to start throttling your activity. I don't know if that's where he was going with it, but those are the kinds of things we've been thinking of.
Yeah, and then there's also a question about the scripting engine. Is it going to be an option to use other languages, or does it have to be the same way that you have demonstrated?
Yeah, right now, that's a embedded Lua environment, similar to how Nmap does it. So it doesn't allow for me to say, let's interpret a different language. And I don't know if I'd want, I mean, I haven't honestly, I haven't given it much thought, but I'm not sure how I feel about claiming we'll support all sorts of different languages. I like the simplicity of Lua, how just about anybody could probably pick it up, and it's easy to look at, easy to read, I think. So, but of course, who knows? I'm open to anything people want to talk about as far as possibilities. I like the way Nmap does it. So I've used Lua, embedded Lua environments in previous projects and previous lives, and it's worked out really well for me. So I'm kind of biased, I guess you could say, to doing it this way.
Let's see. I think we have time for a few more questions. How to make sure resolvers giving good results with time? If they start to act bad, do we have any way to detect them using Amass and exclude them in the next run?
Interesting. So currently, Amass does have some code in there that, as I mentioned, it watches the performance, and it does try to it tries to notice if some of them are just not answering the queries anymore, and eventually just not using them any longer. But it doesn't record that, as the person that asked the question said, in order to, say, make a bad list or something like that. So while it's not impossible, it's not currently being performed. Also, Amass used to have the ability, it was removed, at least temporarily, to do this kind of like voting system where it would it would query the same query to 3 different resolvers, and then pick the answer that 2 out of the 3 provided, and mark the one who gave the false answer, as less reliable or something like that. There were different reasons why it was taken out, at least for now. But assuming it was re-implemented safely, it could be useful to further catch these unreliable resolvers, even the ones that slip through DNS validators. So there's possibilities or room for improvement in this area, especially if, again, we maybe had people that wanted to dig into it, learn more about it, and implement it really well for us. Excuse me.
Yeah, no worries. There's one last question. I think you already mentioned this, but for people that have more questions, want to contribute, where can they contribute to the project, or how can they contribute to the project? And if they have any more questions, where can they ask their questions?
Yeah, so if you go to the repo README, the chat link is right there, and it'll bring you to the Discord server. That's where all the questions are being thrown around, the debates, potential debates about why is it being done this way, can we do it better? And it's really the place where, if you want to get the conversation started, you want to get the debate going, then definitely come there. And usually these discussions end up ending with someone saying, yeah, that sounds like a great idea, or that's probably what we should do. Can you write up the feature request? Or do you want to write it, contribute that yourself and raise the PR and things like that? So definitely the Discord server.
Well, sounds good. Again, if you have any more questions, as you heard, head over to the Amass Discord server. Before we let Jeff go, please give him a big thank you in the chat. It was an honor to have you on here, Jeff. I appreciate all the work, and I look forward to seeing where Amass goes in a year from now.
Yeah, thank you. This was a great opportunity to, reach out a little more to the community, help the community in the process, and yeah, please don't hesitate, anyone, to come visit us at the Discord server. Thank you, Ben.
Awesome. Thank you so much, Jeff.